Hello everyone, I am Mithun, currently studying in Sri Venkateswara College of Engineering, Bengaluru. So welcome to the Evolutes and Involutes. Welcome to the exploration of evolutes and involutes, two fundamental concepts in mathematics and engineering. And this presentation will provide an in-depth analysis of intricacies and applications of these curves, shedding light on their significance in various fields. A diagram illustrating the relation between a curve and its evolute and involute. An involute is the locus of the center of curvature. It can't be a locus of center of curvature. And while an involute is the path traced by a point on a taut string that unwinds from a curve. Understanding this definition is crucial to comprehend their properties and applications. So, involutes. A curve that is obtained by attaching a string which is imaginary and then winding and unwinding is tautly on the curve is given by involute in differential geometry. Involute or evolute is the locus of the free end of this string. So evolutes, the evolute of an involute of a curve is referred to be the original curve. In other words, the locus of the center of curvature of a curve is called evolute, and the traced curve itself is known as the involute of its evolute. So this is a part of a special branch of geometry we call it as differential geometry of curves. It takes about the smooth curves which lie in Euclidean space and application of different methods of integral and differential calculus on them. And the shapes related to some other curves are called as involutes. And this was discovered by Christian Huygens in 1673. It was a Dutch physicist and was a physicist. So properties of evolutes and involutes. Evolute exhibit a property such as envelope and pedal curve, while the involute are characterized by tangential circle and curve generation. Understanding these properties is essential for their practical applications. So let us study the involutes of different curves as shown below. So involute of a circle, involute of a catenary, involute of a deltoid, involute of a parabola, involute of an ellipse. So involute of a circle, it is similar to the Archimedes circle spiral. It is similar to the Archimedes spiral. Next we have involute of a catenary. In involute of a catenary, it is a curve which is similar to the hanging cable, supported to the to ends, supported to ends here. So it is a U-shaped hanging chain which looks like a parabola. So that traptic is the involute of a catenary to the vertex. So involute of a deltoid. It is a tricuspid curve with three cups. We have three cups here, one cup, second cup, and this is a third cup. And it is resembles the Greek letter delta. So it is known as the deltoid. So involute of a parabola. We have one semicircle parabola, another semicircle parabola to form parabola semicircular parabola. So involute of ellipse, we have upward, uh, you know, uh, cone, and we have downward cone to form ellipse as shown in the figure. So mathematical formula. So as a graph showing the parametric equation of an evolute and involute, the mathematical representation of an evolute and involute involves the intricate calculus and parametric evolutions, equations, and the differential and integration of these equations provide valuable insights into the behavior and characteristics of these curves. So here are the equations for circular involute, catenary involute, deltoid involute. Circular involute, where x is equal to r into cos t plus t sin t, where y is equal to r sin t minus t cos t, where r is the radius of a circle, where t is the parameter of a angle in radian. And we have catenary involute, where x is equal to t minus tan h t, where y is equal to sec h t, where t is be the parameter. Deltoid involute, where x is equal to 2r cos t plus r cos 2t, where y is equal to 2r sin t minus r sin 2t, where r is the radius of rolling circle involved in formation of deltoid. So, involute of a circle. Involute of a circle is a practical concept and also have various life, real life application. It is mostly used in, designing cogwheel or tooth wheel, which are used in rotating machines. It looks like an Archimedes spiral. Its parametric evolution are shown below. In Cartesian coordinates, if r is the radius of a circle and the angle parameter is t, then x is equal to r cos t plus t sin t, where y is equal to r sin t minus t cos t. So in the polar coordinates, if r and theta are the parameter, then r is equal to a sec alpha, where theta is equal to tan alpha minus alpha, where a be the radius of circle. And when we talk about arc length of the circular involute, the length of the arc of the involute of the circle is given by L is equal to R by 2 into T2. So let's learn how to draw involute by following given steps. So draw a few number of tangent to points given on the curve. Write the tangent on the to the points that is on the curve. So pick up two neighboring tangent lines. So pick up in two neighboring tangent lines and extending this opposite direction. In the opposite direction, we obtain an intersection point here. So taking that endpoint this as an as a center. So the distance between the center and the point of the first tangent should be taken. So here will be distance from the center and the tangent of the first point is given to be as an arc here. So as shown in the following figure, let L1 be the line 1, I mean the tangent 1, and L2 be the tangent 2. They intersect at X, so they form an arc here, A1. Whereas these intersection points are X and XA. So let us take another two neighboring point L2 and L3. So take a distance here from here and intersect at a point Y. So extend this. So we obtain YA1 and YA2 and join this A1 and A2 to form an arc here. So repeat the same process for the rest of the tangents, and this way we will get a curve of arcs constructed by now, and we will get the required involute of the curve. So geometrical interpretation. A geometric illustration demonstrating the transformation between a curve and its evolute and involute. From geometrical standpoint, evolutes and involutes offer captivating interpretation in terms of curvature, tangency, and shape of transformation. And these interpretations provide a valuable geometrical insight into the behavior of the curve. So, engineering application of involutes and evolutes. Evolutes and involutes find extensive application in engineering, particularly in designing of gears, cams, and various mechanical systems. And these precise curves and properties are instrumental in ensuring smooth and efficient operation of this mechanism. So we have biological and natural phenomena here. A photograph capturing the intricate pattern of seashell, showcasing the manifest of evolute and involute in nature. Interestingly, evolutes and involutes are manifest in biological structure and the natural phenomena such as formation of seashells and the growth of certain patterns of plants. And this observation highlights the universality of these curves in the natural world. So the involutes of a curve have many applications in industries and business. Gear industries to make teeth for two revolving machines and gears, and scroll compressing and gas compressing. These are made in this shape to reduce noise and to make them efficient. And the incorporation of evolutes and involutes in robotics and automation holds promise for enhancing the precision and efficiency of robotic moments and the manipulations. Understanding the dynamics of these curves is crucial for advancing the capabilities of robotic system. So we have in conclusion, the exploration of evolutes and involute reveals their profound significance in mathematics, engineering, and natural phenomena, and their intricate properties and diverse application, and the potential for future advancement underscore their enduring relevance in various domains. Thank you.